C provides a very useful iteration loop control called the for loop. Let's see how this works. We're going to take a working copy of working.c and paste it into the working project and open it up in the editor. First, let's just create a simple while loop. And this is actually an example from a previous movie. We'll say int x equals 5, while x, and we'll printf the value of x, and then we'll decrement x using the decrement operator. So this initializes x to 5, and then the first time through the loop, obviously 5 is still true. As long as it's non-zero, it's true. Once it hits 0, it becomes false, and the while loop will end. So it'll print a 5, and it'll decrement, and it'll print a 4, and it'll decrement, all the way down to when this gets to be 0, then it'll stop the loop, and it won't print 0. So it'll print 5, 4, 3, 2, 1. So we'll save that and run it, and there we have it. X is 5, 4, 3, 2, 1. The purpose of the for loop is to be able to do all of this on one line. So let's go ahead and create this as a for loop. We'll say for x equals 5, while x, and decrement x. And we'll printf the value of x. And let me declare x here with an int. So this for loop is exactly the same as all of this. And it's really just 2 lines of code, unless you count this closing brace. So we've reduced the amount of lines of code, and we've made it actually simpler. Now, this might look cryptic at first if you haven't seen this before, but once you get what this is, it's a lot simpler. So I'm going to go ahead and delete the while version, and we'll just take a look at this. The for loop takes 3 clauses in the control section. The first clause is the initializer, and here we say int x equals 5. The second clause is really the while control, while x, and the third clause is do this at the end of the loop before we start the control again. And so here we decrement x. So it's exactly the same code that we had in the while loop. And so when I save this and run it, you'll see we get exactly the same result, 5, 4, 3, 2, 1. Now it's much more common to do this like this. Say int I equals 0. And people tend to use I because this is an iteration control. While I is less than 5 and increment I. So if you want to do something 5 times, you make a for loop like this, and you say I equals 0 while I is less than 5. In C, it's tradition to start things at 0. So testing for while I is less than 5 actually ensures that it happens exactly 5 times, because when it gets to 5, you've done it 5 times and it'll stop. So if we run this, it'll say I is 0 through I is 4, and there'll still be 5 lines. I equals 0, 1, 2, 3, 4, and that makes 5 lines. So that's a really common way to do this. Also, you'll notice that I'm able to declare and initialize the variable inside the for loop control. This is one of the few places where this is allowed in C, and actually this wasn't allowed in C until C99. So it's only been the last version of C. Of course, we're at C11 now, but until recently, C99 was the latest version, and before that, this wasn't allowed, and what you had to do is you had to do something like this. Int I, and then say for I equals 0. And since it's such bad form to declare a variable and not initialize it, it's really prone to errors if you end up using that variable for something else. So you would see this, int I equals 0, and then nothing in the initializing clause of the for loop. So here we'll see we get exactly the same result. Save it and run it. And we have this sort of odd looking for loop like this. And so when C99 was ratified, this became legal, and it made it a whole lot simpler and a whole lot more common. And it has the added benefit that this particular version of I is really only valid inside of this loop. Outside of this loop, if you had an int I declared outside of it, it would be a separate variable than the one that's inside the loop. So you don't have your namespace pollution that you have the other way. Now let's take a look at an example of how to iterate through an array, because this is another common use of for loops. Let's create an integer array. We have 5 elements, and we'll go ahead and terminate this with a null. We'll put a 0 at the end. So we have 6 elements, and the last one is the terminator, and it's a 0. And again, that's a common pattern in C. And so we'll declare an integer pointer here, and we'll initialize it to IA. And remember, with an array, the name of the array can be used as a pointer. It's an immutable pointer, but it's still a pointer. So I can assign it to a pointer and use that as an iterator. And while what's pointed at it by IP is not null, so that just looks like that. And then we will increment IP, And down here, instead of I, we'll say value is, and it's what's pointed at by IP. So let's take a look at this real quick. We have an integer pointer and we're initializing it to the beginning of the array, the first element in the array. And then we're testing for what's pointed at by that pointer to see whether it's null. When it gets to null, this test will become false and the loop will stop. And then we're incrementing the pointer at the end of the loop. And in the loop, we're simply printing the value of the pointer. So this should come out saying value is 1, 2, 3, 4, 5. So I'm going to save that and run it. And here we have value is 1, 2, 3, 4, 5. So that's actually a pretty common way to step through an array using an integer pointer or whatever type that array is, that pointer as an iterator. So the for loop is a fundamental control in C. It's incredibly powerful and useful. And while it may look cryptic at first, once you get to know it, you'll find a lot of uses for it. Let's go ahead and delete our working file and run clean to get set up for the next lesson.